Hi Olympians. So today we are going to start a new subtopic in the main chapter of local anti-infectives. For a quick recap, our first video was about basic structures and nomenclature. The second one is anti-infectives. In anti-infectives, we have covered local anti-infectives, and the second topic is preservatives. So let's get started. What is the definition of preservatives? Preservatives are the substances which are added to pharmaceutical formulations or preparations in order to prevent or inhibit microbial growth. The main one is microbial growth, such as bacteria, fungi, mold, etc., which would degrade the quality or sacrifice the safety of the product. Now, what do we mean? Preservatives are added to formulations in order to prevent the growth of microorganisms. Now, what are these microorganisms? These microorganisms can be one of three things: fungi, bacteria, and mold. Next up, what are the ideal properties of a preservative? The ideal properties of preservatives are they should be non-toxic, non-irritant, and compatible. Now we know non-toxic, non-irritant because it has to be applied on the skin, or it has to be ingested orally. It should be non-toxic and non-irritant. Compatible. What do we mean by compatible? When the preservative is added with a active pharmaceutical ingredient, it should not be toxic, nor should it give a incompatibility. Next is it should be able to exert wide spectrum of activity. What do you mean by wide spectrum of activity? If in a formulation there are three things like fungi, bacteria, and molds, so a preservative should be able to exert its action on all three microorganisms instead of just one. So when it shows its action on different type of microorganisms, we call it a wide spectrum of activity. Next is it should be potent. That is, small concentration should give more effect. Potent as in, instead of adding, if a formulation is 20 ml, we should not be adding 10 ml of preservatives. We only should be adding 0.1 ml of preservatives. So, potent here means a very small quantity which is able to show its effect in a larger scale. So, this would be potent. Next is it should maintain the activity throughout the product manufacturing. Not only during the early stages, it should show its activity throughout the product manufacturing. That is from the start, that is from the raw material mixing until the administration in patient, it should show its activity. Now examples of this is alcohol, boric acid. Now, what is the need for adding preservatives? The need for preservatives is to increase the shelf life of the drug, protect the drug or the API from microbial attack, stabilize the products, enhance the activity and efficacy of the drug. Now, what all? To increase the shelf life. That is, if you add preservatives, the shelf life will increase from 2 months to maybe 1 year. So, we increase the lifespan, that is the shelf life of the drug. Next is to protect the drug or API from microbial attack. Now, if we do not add preservatives, the formulation will get spoiled because of due to microorganisms. So, we should be adding a preservative to inhibit the spoilage of the formulation due to microorganisms. Next is to stabilize the product. Some of the products are not stable in their original conditions. That is, if there is some water present in the formulation. If there is water in the formulation, then we can totally expect some mold to grow here. So, to prevent that and to make the formulation stable, we have to add another preservative. Next is to enhance the activity and efficacy of the drug. Sometimes preservatives can also act to enhance the activity and to increase the efficacy of the drug. Now let us check at the classification. So the classification is based on the mechanism of action, source, and chemical composition. So what are they classified on the basis of? Mechanism of action, source, and chemical composition. Now let us start one by one. Now, on the basis of mechanism of action, the antimicrobial agents are classified into three categories. First is antimicrobial agents, second is antioxidants, and chelating agents. So what are the three? Antimicrobial agents, antioxidants, and chelating agents. Now, antimicrobial agents, what will these do? This will help in the killing of the microbes. So antimicrobial agents. Antioxidants, what will these do? Now, one of the action of the microorganisms is it will cause oxidation. Oxidation of the formulation. So, if there is oxidation of the formulation, it will be unstable. If it is unstable, it will get spoiled. So, one way is to kill the microorganism. The second way of controlling microorganisms is you stop the action of oxidation, and the third one is chelating agent. So if you find something microorganism or maybe a heavy metal, what you do is you form a complex with it. So if you form a complex with it, the microorganism or the heavy metal will not be able to do its job, that is it won't be able to show its action of oxidation. So if it is not able to show its action of oxidation, there would not be any spoilage. So if you add a preservative, what will be this? There will be a complex formation, so there will be no action of oxidation. So no oxidation means no spoilage. Now what are our examples over here? The examples of antimicrobial agents includes benzoic acid, sodium benzoate, methyl paraben, propyl paraben, and phenol. Now the antioxidants includes vitamin E, vitamin C, butylated hydroxyanisole, for short it is BHA, butylated hydroxytoluene, that is BHT. Next is chelating agents. So let us see each one separately. Now in antimicrobial agents we have benzoic acid, sodium benzoate, methyl paraben, propyl paraben, and phenol. So what all we have? We have two acid salts, one acid and one acid salt, that is benzoic acid and sodium benzoate. So benzoate can also be written as benzoic acid. So it's a salt of benzoic acid. So sodium benzoate, benzoic acid. We'll group these two together. The parabens together, that is methyl paraben, propyl paraben, and the alcohol separately, that is phenol. Next we have antioxidant agents. So we have antioxidants are vitamin E, vitamin C. So we will group these two together, the vitamins together, vitamin E, vitamin C. Then we have BHA and BHT, that is butylated hydroxyanisole and butylated hydroxytoluene. Next we have the chelating agents. In chelating agents we have three, that is ETTA, ethylene diamine tetraacetic acid, and the last one we have, the last two we have is, next we have citric acid and polyphosphates. Now let us look at the structures of antimicrobial agents. Now in antimicrobial agents we said benzoic acid. So what is it? Benzoic acid. Benz means a benzene ring. Oic acid is C double bond O H. So C double bond O OH. So benzoic acid. Next we have methyl paraben. Now if we see methyl paraben and propyl paraben, what we will see is the common structure of parabens is something like this. A benzene ring with an OH group. Attached to this OH group is a C double bond O and a R group. So this is a paraben group. Okay. So a paraben group. Now if it is methyl paraben, instead of R we will add a CH3, and if it's a propyl paraben we will add CH2, CH2, CH3. So methyl paraben 1 CH, propyl paraben 1, 2, 3, 3 carbons. Methyl paraben 1 carbon. So what is a paraben? Paraben is a OH, and in the para position we will have C double bond O and the R group according to the first word, propyl paraben or methyl paraben. Next we have sodium benzoate. In sodium benzoate we have the sodium salt of benzoic acid. So we'll draw benzoic acid first, and replacing the H with O minus Na plus. So sodium benzoate. Next we have phenol. Phenol is benzene with an OH ring. So next up we have antioxidants. In antioxidants we have ascorbic acid, butylated hydroxyanisole and butylated hydroxytoluene. So first we will see ascorbic acid, or also known as vitamin C. So in vitamin C we will have a 5-membered furan ring. Okay, attached to it would be double bond O, OH, another OH, then 2 carbon chain. Along with each carbon there would be a OH group attached. So this is a ascorbate or ascorbic acid or vitamin C. Next we have butylated hydroxyanisole. So butylated hydroxyanisole, so first we will draw anisole. Anisole is a benzene ring with the OCH3. Now what do you mean by butylated hydroxyanisole? So in the para position of this anisole group, that is OCH3 group, we will add a hydroxy, that is OH. And since it is written as butylated, butyl means 4 carbons, so it's a carbon attached to 3 carbons. So this is a butylated hydroxyanisole. Next we have butylated hydroxytoluene. So first we will draw toluene, that is a CH3 group on a benzene. Now to this we will add in the para position the hydroxy group, and in each of the meta positions we will add a C connected to CH3 CH3s. So we have a butylated hydroxytoluene, ascorbic acid, butylated hydroxyanisole and butylated hydroxytoluene. Next up we have our chelating agents. In chelating agents we will look at the structure of ethylene diamine tetraacetic acid. Now how do we remember this? Take the first word, ethylene. How do we draw ethylene? C attached with a double bond with another C. Now we will add diamine. So diamine means 2 amines. So attached to this would be a nitrogen. Attached to this carbon will be another nitrogen. Now to complete the valency we will add H and another H. Then diamine tetraacetic acid. Tetraacetic acid is 1, 2, 3 and 4 acetic acids we need to add. So here we'll add one CH3COOH, another here CH3COOH, another one over here CH3COOH, another one here CH3COOH. So we have ethylene, diamine, tetraacetic acid. Next we have on the basis of source. So on the basis of source we will classify them as natural or synthetic. So natural would be lemon oil, neem oil, sodium chloride, honey. Sodium chloride is Na and Cl. Then we have synthetic, benzoate, sorbates, propionates and phenyl mercuric nitrate. Now the synthetic ones are sorbic acid and phenyl mercuric nitrate. Sorbic acid, which is a 6 carbon chain which ends with a COOH. So let's start 1, 2, 3, 4, 5, 6. So it's a 6 carbon chain with a COH group. So 6 as in including the COH group there are 6 carbons. Next we have phenyl mercuric nitrate. Now phenyl means there would be a benzene ring. Mercuric, mercury. The nitrate is given as NO3. So an oxygen attached to it, a nitrogen, another oxygen and another oxygen. So we have nitrate. So this will have a positive charge, this will have a negative charge since the valency is not balanced. Next we have on the basis of chemical composition. On the basis of chemical composition we have para hydroxybenzoic acid derivatives and the miscellaneous ones. So the para hydroxybenzoic acid derivatives we have methyl paraben and propyl paraben. Then in miscellaneous ones, we have benzalkonium chloride, phenyl mercuric nitrate, and phenyl mercuric acetate. So let us check. Para hydroxybenzoic acid. So what we have in the para position, we have a hydroxy group, and then we have a benzoic acid group in the subsequent position. Next we have methyl paraben. So we will attach a CH3 here instead of the R group here. And then propyl paraben, we have a 3 carbon chain instead of the R group. In miscellaneous, we have phenyl mercuric nitrate and phenyl mercuric acetate. As we had seen, phenyl mercuric nitrate is phenyl. First we draw a phenyl. We go according to what the name says. Phenyl. Then we have mercuric. So we'll draw a mercuric compound. Then a nitrate. So we'll write a nitrate. How is a nitrate? NO3 minus. So O, N, O, double bond O. So here there's an extra bond. So a positive charge. Here there's a less bond, so a negative charge. Phenyl mercuric acetate. So phenyl mercuric acetate. Now, so how do we write acetate? CH3, C double bond O, O minus. So this O minus will attach over here. So we'll get O, C double bond O, CH3. So phenyl mercuric acetate. Next we have the synthesis of methyl paraben. So the synthesis of methyl paraben, we will start with para hydroxy benzoic acid. So we take para hydroxy benzoic acid, we take ethanol in the presence of sulfuric acid. So there would be esterification. So there is an alcohol and an acid in the presence of H2SO4. So if you add an acid to an alcohol in the presence of a strong acid, for example H2SO4, there will be dehydration, that is removal of water, and you will get a ester. So what we got over here is methyl paraben. So this H group will be replaced with this CH3 group. So we will get this one over here. Now let us see how we get acid plus alcohol in the presence of strong acid gives ester. We have acid, that is R, C double bond O, OH. Then we have an alcohol, that is R, O, H. Now if we remove water from here, we will get R, C double bond O, O, R, which is an ester. Ether, which is an ester. So the ester over here is methyl paraben. Thank you. That was all we had for today. I hope you enjoyed the class. Please subscribe and like our channel. If you like the video and you want to see more such videos, please comment. So that was all for today. Thank you. Happy studying. Bye bye.